All right, so if there's no questions, I started the recording. We're going to begin now. Cool. So last class, as I typically do with the first classes, it's mainly the goal of the first class is to sort of set some sort of stage, tell you kind of what the story is of this class. And the story of this class, we have 18, 1, 2, 3, 4, 5, 6, 7, 8. How are there 13 of you in here, but yeah, 17 watching? So everybody's here. How cute. We think, though. So one of the goals of this class is to develop tools and probability that sort of allow us to answer questions about the collection of data. That's sort of what we want to be able to do. And so the first homework that I gave you was essentially asking you to read the book. Now, I can't encourage this enough. And by the way, if you click on the syllabus for this class, you'll notice that, what is this? Oh my God, I don't know what's the course summary. It has all the lectures here. If you click on, it's not there. Why did it disappear? That's interesting. Anyhow, I have a PDF version of the book, Don't Tell the Authorities, and it's going to be posted on Canvas. Read it. Read it again. Read it even more. Ask questions. I mean, look, one of the ways that one of the things you have to understand, particularly in math and science at this level, at the university level, is we can't, even if we wanted to, do every example in a book and go through every detail. The learning is on you guys. I'm a resource. It begins and ends with you. You got to read the book. You got to understand how to read a book in science and math. It's not a novel. You don't go fast. You go slow, AF, as you like to say. And you take notes and you ask questions and you say, it might take you a half an hour to read one page. That's sometimes what it is. Sorry. And most of us are human and we learn slowly. Some of this stuff is hard. And you have to expect that and whatnot. So anyhow, I thought it was on here, but it's not. So I'll fix that for you. I'll put it up there and I guess I can't do it now, but I can do it soon enough. Okay, so let's start it off this way. So here's what we did. So we said last class that statistics was about collecting data, whatever that means, and analyzing it. So what we have to figure out is how are we going to do that? How will we collect it? And then once we collect it, how do we analyze it? So there's lots of words in stuff. If you read the first, especially the first chapter of this book, there's lots of words. It feels like this, it's almost like a vocabulary class where you got, descriptive, inferential, you have sample, you have all these words, and it's like, this means this means that. First and foremost, I am never going to put on a test, define a term. It is 2020. Why would I ask you to define something you can easily look up on your phone? That's not the point. But what you need to do is you need to be familiar with terms. You shouldn't have to look, if you're in a statistics class, you shouldn't have to look up every time you see the word quantitative or qualitative. You should have an idea of what that means. When we're in the context of a statistics class or we're in the context of statistics, you should know the difference between a sample, whatever that means, and a population. So the first section, the first chapter of your book, that's much of what it's about. It's about getting you to become familiar with these words. Because these things are very, very, very important. To give you a real world example, if suppose we wanted to learn about the average height of an adult, well, we clearly can't go and measure every human being on the planet, right? We clearly can't expect every human being to answer our email and tell us their exact height. So that's not a way to measure the average height of an adult. So instead, what we do is we hope to take a sample of all the adults. And then we say, okay, we'll ask these adults what their height is, or we'll measure these adults. But then the problem becomes, is my sample giving me any information about the general population? So think about that. Let's think about that again, and let's put it in a different phrase. Suppose we wanted to know the wealth of the average adult. Does us polling people who live in Pittsburgh give us a full picture of how the average adult's wealth is distributed in the United States or the world? Absolutely not. Well, I hope you realize absolutely not. You probably don't. Hell, we get up in the morning and we go to the bathroom and clean water. What the hell do we know about poor? You ever think about that? You stand under clean water for 15 minutes in the morning, and then you go to the bathroom and clean water. You can, Joey, it's a first world problem, but it's a true one, right? Think about that, right? So things like wealth and stuff, we can't get a full grasp on that. So what we need to do is we need to have terms, and we need to have sort of a way of even thinking about collecting our said data, whatever that is. And then once we do that, we can hopefully at some point think about analyzing the data. Okay. So the best way to learn, I think, is in a class like this is not to just spew out definitions, is to think about a real world sort of scenario. So let's pick one of those scenarios that we wanted to study. So suppose we're interested in the heights or the height of all adults. 18 and over on Earth. You know, suppose one day you're sitting at Chuck E. Cheese with your posse and you're like, hey, I wonder how tall everybody is, and let's do a study, right? So it seems impractical, if not impossible, to measure each person exactly. We get this, right? I mean, I hope you get this. I mean, how are we going to measure every person over the age of 18? You'd have to have a lot of friends all over the world that you can help you with this. So what we might do is we might ask ourselves, okay, since that's impossible, do we just give up or do we try something else? So instead of giving up, we might try to measure, say, 10,000 adults. So in order for us to be very clear with whoever's going to read our little investigation or our study, we have to make sure it's clear to them that they know when we went to study adults, we clearly didn't look at every adult. We just took certain adults. So what we're going to do is this suggests we distinguish the two. So what I mean by that is we do the following. We call all adults the population. We call the 10,000 that we study a sample of the population. So what this does is this helps us. This helps us inform whoever's going to be interested in our investigation. That A, we didn't possibly try to study every human being that's over 18. And so what we need to do is, if we're going to do this not just for this investigation, but for other studies, we need to come up with useful terms that everybody can agree on. We do this all the time. We call that a ceiling. We call that a floor. We call this a board or a wall. You know, I might call this a mobile, depending on where I'm from on the planet. I might call it a cell phone. I might just call it a phone. This is a cup, right? We give names to things. That's what we do. When you were born, you got a name, so we can distinguish you from someone else, right? Does this make sense? We're giving names to distinguish two different things. That's what we're doing right here. Any questions, comments? All right, very good. Okay. Now, say we go and do this study. So next we go out with our team. And we measure all 10,000. Did I say 10,000? I forget, or 100,000, 10,000. In our sample. So we're going to give a name to these. We call these heights. The general name for these is we call these heights data. That's our data. More particularly, we call them quantitative. Why do we call them quantitative? Because each height is a numerical value, right? So quantitative data is any data that has a numerical value. So if you read the book, they'll say definition. Quantitative means it's numerical. Then they'll say qualitative, which I asked you about in the homework too. What is qualitative data? That is non-numerical data. Whatever that might mean, you can think of some examples. So I guess I should be more clear here. We call it quantitative data. Some people might call it variables as well. You might see that word in the book. But I don't like to use variables unless I have to, because you guys get confused with the word variable here from variable from like an algebra class, because you're not that experienced. And we'll use variable when it's appropriate, but you got to learn now that some of these words have multiple meanings depending on context. You're an adult now, just like you have to understand when to use two, and two. You got to learn when variable means one thing versus the other. Does anybody have a question, comments? Anybody want to say anything?
I guess I'll ask this question.
Sure.
What is like other numerical values? Like if you were to do it as maybe weight, then I guess too, or
Yeah, for sure. If you wanted to measure the average weight, that would be a numerical value as well. Does that make sense?
Yeah.
Now, if you're measuring height of someone, then so maybe perhaps what you're hinting at is an example of data that is maybe qualitative. Is maybe that's what you're hinting at?
Yeah, like what makes it qualitative?
Qualitative can't be written as a number. So So qualitative could be, okay, the most basic one, although I shouldn't say this now, someone will sue me. A very basic one, okay, I won't say that one. Qualitative data might be the name of a state. Maybe we want to study temperatures, distributions, and maybe we're going to list states from high to low as highest average or something. So you might say Arizona or California. Does that make sense?
Yeah.
So the data you're studying is not a number, the data you're studying is a state. Now don't get that confused, however, from if you were studying the actual average temperatures of a state, which would mean the data is then a number again. Does that make sense?
Mm-hmm.
Yeah, and this is important. Look, a good way to remember this is quantify means count, right? And so quantitative, anytime you hear quant. By the way, if you want a really good job, go become a quantitative risk analyst. They make a lot of money. They start about $1.50 a year. 1,000. Of course, you have to know a lot of math, which everybody always tells me in this class, I hate math, I'm bad at it. That's what you guys always tell me. That's when you should invent a time machine, go back to your school days and say, all my teachers that taught me math, I want to redo. Anyhow, are we cool with this so far, guys? We good? Yep. Here's an interesting word that comes into play oftentimes in when we're doing statistics. So we call. That was good, Phil. Every once in a while, you guys just got to type something if you're at Zoom, so I think you're awake. I'm just kidding. You know, when I'm in meetings, I just put the black screen on and I mute myself and take a nap. No. But not when I'm paying 35 grand a year on. I
want my 50 cents back from Zoom meetings.
What's that?
I want my 50 cents back.
I know, Austin, you better throttle back. That's what I said to you guys. I've put in more work since April than I ever have. I'm kidding. You guys should pay me more. I'm just kidding. Actually, you guys don't even pay me. I don't think that's how it works. We should get into the finances of how higher institutions work. Although maybe we don't want to get into that. Okay, so here we go. So we call, or let's note this. So we note theoretically, I mean, it's not likely, that heights can range from 0 to whatever, right? I mean, we know that it's very unlikely that you're going to be 1 inch tall, but it's theoretically possible that you're a certain height, right? Or maybe not 0. Maybe we say the average adult or the smallest adult on record is 3 feet 2 inches. I don't know, whatever it is. The point is it can range between any two values. So because of this, we say that our data is continuous. And this is important later on. So for those of you who have been in a math class, you've probably seen the word continuous maybe in a calculus course, and it has a very, I don't want to say the same meaning, but the way you think about continuous, put it this way, if you measure the heights of people, it's not like it's going to be the counting numbers. Not everybody's going to be 3 foot, 4 feet, 5 feet, 6 feet, whatever, right? There's going to be everything in between is a possibility. Right? So we say it's continuous. Now, if you're looking for something that's sort of the opposite of that, what would be the difference between that? Well, the difference between that is you look at on your homework is we call it discrete data. Discrete data would be something that only takes a specific value. Or excuse me, that can only take certain values. So a good example of this, here's a great way to understand the difference between discrete and continuous data. If I wanted to measure foot size would be continuous data. Shoe size would be discrete, because we only have certain sizes of shoes, right? You understand what I'm saying there? So shoe size would be discrete data. Foot size would be continuous. That's a good example to kind of ponder. And you can think of many more. By the way, the world is very useful now. If you just Google examples of discrete data, they're going to give you examples, right? If you Google examples of continuous data, you're going to get cool examples. Chemicals. I have a love-hate relationship with them. You guys having fun yet? Have you learned to love me as platonically as I love you? What shows are the kids watching now? Anything good? Anything I should watch? No? Oh. Macintosh, come on, bro. Usually good for something. All right, any typos yet by me? I don't think so. Very good. I love. All right. Are we cool here? So what I wanted to do is, instead of just, look, you can read the book and see these definitions in all their glory. I mean, it's very silly for me to come in here. I never found that to be an effective thing for me to write definitions down like a book does. That's what the books are for. Here's a cool thing about school. Do you guys know where like lectures came from? Do you know like what started lectures and why lectures even exist? It dates back to like the Middle Ages and the times long before that everybody had books accessible. So the way we gave information a long time ago was someone who had the information and had the access to the books would go to a room like this and lecture it, and you would take notes because that was the only way for you to get the information. And here we are some hundreds of years later still doing it in some way. I try not to do it that way, but some classes lean that way. Like, you can't really teach a calculus class. You have to do a little bit of that. But here, I'm trying to illustrate ideas through an example. And I would encourage you to, you know, when I gave you the first homework, you'll notice the problem say describe the difference. And I don't want you to make definitions. I want you to describe in real words what these things mean. Anybody have a question about this? Comment. Okay, so what's next? Okay, so we'll change colors. I love to change colors. We'll get this nice blue. After some time, we have collected our heights. But what is the heights? The heights are just another name for our data. So the big question is, what do we do with it? I guess this is questions, preguntas. What do we do with it? What conclusions can we make? And then more importantly, is our sample, and this is the key thing, representative of all adults, the population? I mean, these would be important. If we don't know how to answer these questions, then what good is collecting data? Nora, I'm glad you're here. So you found the link, at least. That's the key. It's weird, like I'm talking to these fools typing, right? And you probably feel like I'm just ignoring you, like I'm over here like sliding into my wife's Instagram DMs. I like saying that. I remember that song a couple years ago, and then I'd forgotten about sliding into the DMs. And then Amy watches this goofy show that I have to watch because that's what you do when you're in relationships. That's my wife, Amy. And it's called Younger. Does anybody watch it? I don't know what the hell channel it's on. You watch, you know what I'm talking about? It's about this girl who lies about her age to get a job. It's actually interesting. Hilary Duff's in it. She ain't famous anymore. When I was younger, Hilary Duff was like everybody, oh, Hilary Duff. Right? I don't know now. Can I say that on you? But anyhow, there was an episode where these older women in their 40s, and I'm thinking, I'm 40. I know what the DMs are. I don't slide anywhere because I'm married, but there was an episode about the one lady figuring out she didn't get it. Like she didn't realize it's like on the side piece kind of stuff. Anyhow, it's like, but then they used that term in the episode last night. She was like, Hilary Duff said that Liza, I think. She's like, you don't want to be anybody's side piece. And I said, who wants to be the side piece? And my wife goes, I got to say my partner. That's the new way to say it, right? People, hey, I'm just trying, this is your generation. I'm trying to make sure you're happy with me, guys. My partner. And I'm not even saying this jokingly. I'm being honest. And she says, what is a side piece? I said, Amy, you know this. Oh, she goes, oh, yes. Who would do that? I don't know. Lots of people. All right. But anyhow, it's a weird show. You should check it out. I don't know. The shows you watch. By the way, I should remind you guys that this class is much like a relationship like that. You guys have to pretend to like me and Providence Stats for a few months, right? It's like a relationship. It can be fake, and you're going to do things. I mean, I've told you this story before. You've heard my spiel about this, right? I mean, when I've been with my wife 15 years, you think for a second half the things I did back then or do now that I necessarily want to do? No, I got my eye on a prize, just like you got your eye on a prize in here. You want to get a good grade, get a degree, get a job. You could play fake with me all you want. Slide into my emails like, oh, Grady, I really need to know the answer to this question. I really, really like it. You could be lying, and that's okay. It's all part of the fun. Like you did it perfectly the first day. Macintosh over here emailing me, can I come to both? Oh, no, maybe I do. Oh, I got to eat all this probability up that I can, right? We can make a song about this. I'll have to call up Young Jeezy, or who was it? Who slid into the DMs? Little Troy? No, Little Troy. God almighty. Young Jock or something from. What's up with all these new rappers singing all the time? Face tats everywhere. Creeping me out. All right. Shouldn't mock. So let's get back to this because we have to bring you back in. This is what I do. For those of you who've never had me before, this is what we do. You might think I'm crazy, but I've learned a long time ago that the only way I can get you to pay attention most of the time is occasionally at random acts of time, act like a fool. And then you come back in because you're like, what will the crazy fat bearded man say next? All right, any questions about it? Okay, so what are we going to do with this said data? So an idea as old as time, tale as old as time, beauty and the beast. See how my mind works? So an idea as old as time is to visualize it. Someone's chatting. Yo, Gaudy. Thank you, Phil. I knew it was one of those dudes down south. Yo, Gaudy. What a time to be alive. I'm going to have to add, I haven't heard that. Is it you guys I was telling? Never mind. I'll get myself in trouble. That's what I did. It was and it was like 2016, and whenever that song was popular, I put it on a fine. I was like, where does everybody like to slide? And everybody got it because I talked about it all the time. But a couple people. That's who I knew never came to class, right? See, that was my way of figuring out who really showed up for the test. Ah, smarter than you guys think. All right, so what does it mean to visualize data? Well, I say that this is a tale or an idea as old as time is because long even before we had modern sort of notation and mathematical ideas like algebra and calculus and what we're now going to call probability, what we did know is if we had things, we can collect them and we can visualize. So one of the ways we do that is we visualize through things, you know, through things. That sounds funny to say that. But we visualize them in graphs and charts and things like that. So I never use this orange. If I don't like it, I'll use green. Can you guys see this green? Let's see if you can see this stuff. So there are many ways to do this. So one common way is to group the data. How would we group it? Well, what we do is we group it and we call them classes. I mean, I guess technically we do this now. You're the first year class. See, I don't even say freshman anymore. First year, second year, third year, fourth year. We group people. We do it all the time. So let's just, for the sake of argument, do the following. So in our pretend experiment, we might create classes in the following way. So look, we are allowed to use our intuition. We know that most adults aren't going to be 3 feet tall. Like we have an idea that most adults are probably somewhere around 5'5", right? Ish. You know, we might intuitively think, okay, lots of male adults are around 6 foot, lots of female adults are a little over 5 foot, so maybe somewhere in the middle would be where we think most people are going to fit. Sure, there might be a couple 7-footers, there might be a couple 3-footers, but I don't think we're going to get a 6,000 footer, right? Does that make sense? We're not going to get a 250-foot tall human being. We're not going to get, even though theoretically we could, we're not going to get a 1-inch tall adult. You understand what I'm saying here? So when we want to divide our classes up, we might want to think about a very sort of educated way of doing it. The first thing we have to do, though, is we have to decide what sort of unit are we measuring by. Are we measuring by inches? I don't know, we could. We measuring by centimeters? We measuring by feet? We measuring by meters? I mean, we have to think once those, since we're here in the good old US of A, and the US of A said to the rest of the world, we don't like your way of doing things. We're going to stick to our stupid base 12 way instead of base 10. Think of that could be one of the reasons most of you, not all of you, because you all tell me you sucked at math as a kid. One of the reasons you probably did is because they're trying to make you do measurement with a weird system. Base 10's easy. Base 12 ain't. Think about it. All right. So here's one way you might do it. I might say, okay, here's what I know about heights. I know I'm expecting lots of them to be, between 5 and 6 feet. So maybe I'll divide it up this way. Maybe I'll make a little table. And actually, let's not draw the table yet, because that might not be obvious to your intuition. Let's start from scratch. Let's say class 1, for lack of creativity. Let's say 0 to let's say 4 feet. We'll use feet. Then we'll say class 2. We'll go 4.1 to 4.5 feet. And then we'll say class 3 is 4.6 to 5 feet. And then we'll say class 4 is 5.1 to 5.5 feet. And then we might say class 5 is 5.6 to 6 feet. Now, again, notice the words I'm using. I'm saying we might do this. I ain't saying this is the best way to do it. Who knows? Could be a bad idea to do it this way. I'm just saying we might try this. And then we keep going. I keep writing on the wrong tablet here. We might say 6.1 to 6.5. And then, of course, let's draw a little thing. We'll keep going. We'll do class 7 might be 6.6 to 7. And then let's just do one more class, class 8. We can do 7 up. Again, let me reiterate. I ain't saying this is the best way to get information. I'm saying it's one way. It's an intuitive way. Kids do this kind of stuff. My kids do it. They're 2 and 5. Well, not my 2-year-old yet. Although she kind of does. They know how to group things into things that look alike. Right? That's what they do. All Lydia's Barbies go to one place, and then all the other brand of these weird dolls are grouped this way. I was like, she goes, Dad, did I tell you this story is funny? Why do you like to golf? I said, why do you like to play with Barbie? She says, that's what girls do. And I thought to myself, man, there's a lot of people who hate her saying that, right? What if they don't want to do that, right? I said, why don't you go build some blocks too? Learn a skill now. Got that like old Uncle Bill in your family who's like, that's right, that's exactly what girls do. Everybody got like an old Uncle Bill. You know, I mean, one who says the worst crap ever, but it's okay because they're old. At least people say it's says creepy things to waitresses, says mean things about everybody who don't look like them. We lived a long life, so it's okay. That's what they say. All right. I love getting into these things. You having fun yet? You got your blue wristband on? Yesterday was red. Today's blue. It's like the Bloods and the Crips. All right. Now, of course, this might not be that illustrative. You might take, once you do this, you might want to say, okay, what good is this? And so perhaps we count number of people in each group. So what we can do is we can make a table to illustrate this. And the name we give to this table is called a frequency distribution. So again, let's kind of backtrack, not backtrack, but sort of relax, think about some things. Remind ourselves how much fun we're having. Guess what I'm doing today? I'm going to a concert, believe it or not. It ain't a real concert because we're under the Roni times. It's at a drive-in in Butler. Can you imagine? I don't even know who the band is, but I'm going because it's a night out on the town. I'll think about you guys. For some reason, Macintosh, I look at your shirt. I know it's DI on. For some reason, it made me think of that one of those little rappers I was making fun of, Lil Uzi Vert, who sings. I don't know why it made me think of that. Maybe the Uzi or something. Is he the one that's dead? No. Juice WRLD. The irony of him singing about all that stuff he sang about and then dying from it does not. Oh. Sorry, Joe. You're allowed to think it too. What do they old saying? You live by the gun, you die by it. All right. Anyhow, I do feel bad. So, a frequency distribution, this is just one way of visualizing. So, you know, there's lots of ways we can get quantitative sort of information from this. Oh, excuse me. Does anybody have a question? So like a real ancient archaic way of doing this would even like, I mean, you wouldn't do this right now because there's 10,000 of them, but you would imagine that, let's sort of draw how, I'm going to kill myself. I shouldn't say that out loud, but I really just say that. I keep grabbing the mouse for this computer, but I ain't using that one. I'm using my laptop. And I did it last class too, and it's making me mad. And I apologize. I shouldn't have said that. It was insensitive. They're going to fire me. Oh, boy. All right. So what is one way you might do this? Well, you might list your classes. You know, you might have 1, 2, all the way down. How many do we have? 8? Right? So then you might, you know, may draw, you know, count them. You know, how many are in here? You know, some number. Who knows? And of course, what you I have to understand is all these guys right here must add up to 10,000, right? And by the way, I didn't, you know, and by the way, I do this, I'll do this at the end of the semester for you guys. I do this at the end of every semester for my classes. What I'll do is I'll make, after I get your scores and I go to give you a final grade, I'll list, you know, say 0 to 50 and then 50 to 55, 56 to 60. I'll make classes of all the grades up to 100. And then I'll see where it falls, and that's usually how I make a curve. You know, where is sort of everything kind of falling, and then we adjust your grades accordingly. Does that make sense? And oftentimes, sometimes when you're playing games as a kid, you keep score this way. Does this make sense at all? And I'm going to give you some more concrete examples to do this on, but you could easily do it. You can make things up if you wanted. Just for fun, let's maybe I'll share. Here, let's go to the Google machine. So what I'll share something with you. I don't want to share you my email. That would be mean. Here, let's go here. So if I share you this web page, I'm making tee times in golf. Are you guys at home seeing the internet? I think you are. I hope you are. So I'm going to just Google frequency distribution. And you can see that one of the first things that pops up, I don't even have to finish it. Google knows what I'm talking about, right? This ain't its first rodeo. And then if you just go to images, you'll see that there's a bunch of different ways you might do this. Here's one for incomes. So again, we're not saying that this is what you'd always do. We're saying this is one thing you might try to get information visually from the data that you've collected. Now, maybe us using 8 classes wasn't interesting enough. Maybe we need to use 10 classes or 20, who knows? That's just one way of doing it. Does that make any sense? All right. So let's go back to our whiteboard. So on homework 2, I'm going to give you a couple things. You'll go to the internet, you'll search a couple things, you'll make some tables. And one of the most important things that you want to take from this is how I'm saying these things, like we might try this. And the reason is really, we don't know what we're looking for. We're trying to experiment to get something that pops out and seems useful. I mean, we see this in real time right now with the pandemic going on. I mean, the world, I don't know if it'd be a better place or not if you guys had a more numeracy skills and a better understanding of stats, because the argument is if more people understood the math and science, people wouldn't be feared into certain things and act in a certain way, right? But also the fact that people aren't so numerically inclined and statistically inclined. Many of us interpret graphs incorrectly. We can be misled by things. And I'm not just saying one side or the other. Trust me, the people know how to mislead everybody. It's just what we're good at. I say we're, but as humans, we're good at that. There's no better place of seeing it now than on social media. You go to like some left-wing news site, and they're going to make you look like the end of the world's coming, and they'll have some way of skewing data to make it seem true. You go to the right wing, they'll have the opposite effect. Right? So one of the skills that you should think is a human skill is being able to interpret data better. I mean, if I just put that little housing thing up or income thing that I had on, what does that mean? What does it tell you? Is it giving you anything real? Sure, it's telling us how things are distributed, but is it giving us anything? So I hope that maybe you guys will sort of look at that and think about it. That would be my way of doing that. So an alternative to this, which is very much in the same flavor, is so another visualization is to use what we call a histogram. So here, one way to think about this, here you use vertical bars. And what these vertical bars do is they give us a better sort of way of visualizing these frequencies. So what it might look like in our scenario is if we have our classes down here. So we have, say, class 1, and then we have class 2. So you might have no bar here, and then class 2 might be of this height, and class 3 might be of this height. You might get something that looks like this. Does that make sense, maybe? So you're kind of visualizing it in a different way, and there's more of a visual here because you're seeing, maybe here you sort of visualize more where most heights are concentrated. And perhaps some of you already kind of get the intuition, or maybe you know that heights are what we say in many ways they're kind of normally distributed. And that is sort of, there's this kind of bell curve that happens with things like height. So perhaps we can share a picture of that. And you know what? I didn't even think. I should have done this. Let's do histogram for heights. Here you go. So here is a histogram. Maybe this one. Let's do this one. So here is a histogram of a number of heights. So here the unit of measurement is 200. Here are the 200 centimeters, and they're breaking down. What this chart tells us, excuse me, is that most of the heights happen to be somewhere in the middle, as we would expect, right? If you just go and randomly pick 10,000 people and measure, you would imagine most of them would be in the middle. Very few would be very short, and very few would be very tall. That just seems intuitive to us. Now, of course, if you didn't do it random, if you flew down to Orlando and said, I'm going to go to the NBA bubble and look at the average height, well, guess what? Your data is going to suck. Because it is not going to be representative of the rest of us midgets, right? I shouldn't say that either, right? You get my point, though, right? I hope you get my point. Just like if you got on an airplane and flew to Orange County, California, and went to Laguna Beach and said, I want to figure out the average value of the cars that people own. You're not going to get a representative average value of a car that people own if everybody you look at is driving Jaguars, Teslas, and Ferraris. I mean, hell, you can learn that driving through Pittsburgh. You go to some parts of town, it's Civics and Accords. You got other parts of towns, it's Range Rovers and BMWs everywhere. So that leads into where we want to go next is, what are we doing when we collect this data? Is this data representative? No matter what, if we visualize it, no matter what we can make from these pictures, if you go back to what I was saying before we did this, if I go back a few pages, and please interrupt me if you have any questions. Once we have these pictures, and look, there's other ways to visualize data. I'm not going to go through everything. You guys know there's pie charts, there's bar graphs, there's all this stuff, and you can do that if you want it. I'm just sort of trying to give you a broad picture here. But even if we do that, what conclusions can we make? Now, of course, there's more we can do than just visualize it. You'll notice that after this page, I said one idea that is as old as time is to visualize it. But that's not the only idea. What if we actually did some sort of quantitative sort of work with it? What if we started actually crunching numbers and not just counting how often numbers show up or where they come? But what if we said, why don't we look at different numerical things that we could say, like a common one you're familiar with is the average or the mean, or we might talk about what's the mode or the median. Maybe you know what these words mean, maybe you don't. But then we start getting, not instead of visual sort of information, we get what we call quantitative information. And now, especially in the time that we live, that's a great thing because we have computers that can help us add. We have software that can do things for us. But once again, even when we do that, we're back at the same thing. What conclusions can we make? And even if we think we have conclusions, oh, the average person is 5'8" feet tall. How can we conclude just because we measured 10,000 that that's relatively going to give us information about the population as a whole? So does everybody understand what I'm saying here? So these are the kind of things we want to tackle this semester. And so the first homework I gave you is very much just you knowing definitions and writing about them. The next one I'm going to give you probably this afternoon or tomorrow is more along the lines of what we just did here. And we're going to do some of them together on Monday in class. We're going to actually do an internet search, collect data. We're going to make tables. Then we're going to crunch numbers and all that fun stuff and see what we can do. And then we're going to realize that there's not much we can do in general unless we have more tools, and that's going to lead us into having the study probability. All right, anyhow, does anybody have a question? Let's get you out of here. All right, guys, thank you very much. I appreciate it. Have yourselves a very good weekend if I don't see you. And I will talk to you guys Monday. Thank you very much. Be safe.